Today's video is on fraction division. Many students struggle with fraction division, so I'm going to offer some examples to help you understand exactly what's occurring when dividing by a fraction. In these two examples, these are items that we're definitely familiar with. We know that 30 divided by 2 is 15, and we're familiar with what half of 30 is also 15. And that's the beginning of an understanding between what will work with fraction division by looking at some patterns. If I was to do 30 divided by 3, we all know that's 10. And if I was to do 30 times 1/3, that is 1/3 of 30, we also know that's 10. So as we move down the line, obviously 30 divided by 1 would be 30. And 30 times 1 also equals 30. So the big question is, what happens when we move down to 30 divided by 1/2? And so a lot of students are unfamiliar with what that necessarily means. Now let's try that multiplication problem that's similar and do 30 times 2. Because you can see the pattern growing, you can see the pattern growing, and you're going to note that 30 times 2 is 60. And if you wanted to have a demonstration for 30 divided by 1/2, you could actually take 30 blocks and cut each of those blocks in half. So if I had 30 blocks and each block was cut in half, I would have 60 half blocks. So 30 divided by half would equal 60. Think of it as 30 brownies. If I had 30 brownies but wanted to share them among more than 30 people, if I cut each brownie in half, all of a sudden I'd have 60 brownie pieces. And that's what fraction division is all about, is dividing by a number less than 1. The key concept here is what's known as the reciprocal, or the multiplicative inverse. Because 2 over 1 times 1 over 2 equals 1. 4 over 5 times 5 over 4 equals 1. 8 over 11 times 11 over 8 equals 1. We recognize that that relationship helps us to divide. So if we have an understanding of reciprocals, we can get started with multiplication. So here's a couple of examples. The fraction 3/4, the reciprocal will be 4 over 3, because 3/4 times 4 over 3 equals 1. The reciprocal for 7/8 would be 8 over 7. The reciprocal of 4 is tricky because it only has one term. So we want to rewrite it as an improper fraction, 4 over 1. So the reciprocal would be 1 over 4. And the mixed number is even more difficult because we first need to convert to an improper fraction using the method you guys sometimes know as MA, multiply then add. 3 times 2 is 6, plus 1 is 7 over 3, and then the reciprocal is 3 over 7. A common error students make when doing the reciprocal of mixed numbers is to bring over the whole number and just reciprocal a fraction, which would not be correct. And the other common error is they change to an improper fraction but then forget to flip that fraction to make the reciprocal. So take extra care with whole numbers and mixed numbers when finding reciprocals. Now you can use your knowledge of reciprocals to figure out this problem. We're trying to determine what fraction you can multiply by 4/9 to equal 1. And it clearly would be the reciprocal of 4/9, 9 over 4. If I wanted to multiply that out, 4 over 9 times 9 over 4, 4 times 9 is 36, 9 times 4 is 36. If you wanted to, you could have cross-canceled and had the same answer as well, of 1 over 1. Which equals 1. So here's our first example of an actual division problem. And what you're going to do is use a prescription for success known as remember to reciprocal the right fraction, then multiply. Sometimes I write it in this format to help me remember that it's remember to reciprocal the right fraction, then multiply. Because your divisor has to be your reciprocal or your multiplicative inverse. So I'm going to multiply 3/8 times that inverse, and that will help me to get my answer. Again, once you've converted to multiplication, you can do the cross-canceling or the simplifying on the diagonal or the simplification before multiplication. You cannot do that with division. So once you've converted it to multiplication, go ahead and you can do that process. So 3 divided by 3 is 1, 9 divided by 3 is 3, 8 divided by 2 is 4, 10 divided by 2 is 5, 1 times 5 is 5, 4 times 3 is 12. Your answer's in lowest terms. That's our first successful division problem. If we go to try this one, the same process, you're going to rewrite the fraction. You're going to change to multiplication. You're going to remember to reciprocal the right fraction, and then multiply. Just like in the previous example, you could not do any cross-reducing before you convert, but once it's multiplication, we can cross-cancel the 7 and the 14. The 7 would become a 1, the 14 a 2. 1 times 15 is 15. 16 times 2 is 32, giving us our second final answer. In this example, more of the same. We have 4 over 5. Change to multiplication. We remember to reciprocal the right fraction, and then multiply. You can't cross-cancel the 4 and the 7, but the 5 and the 20 share a common factor of 5. 4 times 4 is 16. 1 times 7 is 7. Now, in this situation, we have an improper fraction, which we will need to convert back into a mixed number. 16 divided by 7 is 2, with a remainder of 2. So our answer will be 2 and 2 over 7. Remember, our denominator stays the same. As we look at this challenging question, we are trying to identify what number we're going to divide 3/8 by to get 12. And the tricky thing is to think about what number you would multiply 3/8 by to get 12. Now, we know that we need our numerator to be much larger than our denominator. So what we're probably going to want to do is set up a 1 as our denominator, because we know that we need our answer to end up being 12 over 1. So 8 times 1 would give us 8. We need a number that's 12 times the size of 8 in order for this to work. So I know that 12 times 8 is 96. So that's really my goal, is 96 up here. So we've got to decide what times 3 equals 96. So 96 divided by 3 is 32. So 32 would work here. So if I did 3 times 32 is 96, 8 times 1 is 8, 96 divided by 8 would equal 12. That would give me my answer. So in my division problem, I would need 1 over 32. So if this had been my brand new problem, and this is what I was asked to solve, I would know that 3/8 divided by 1 over 32 would be 3/8 times 32 over 1. And I would then cross cancel, get a 1 and a 4. 3 times 4 is 12. 1 times 1 is 1. So it's a challenging problem, but there are some problems like that on your homework, and I want you to be prepared for that. The last thing on your homework that I want you to be aware of is sometimes you might be asked to use your order of operations with your fraction division. So in this case, we have 2 division problems, and we know that when we've got multiplication and division remaining, we go left to right. So we got to treat it like as if these were in parentheses. So first we're going to do 1/3 times, remember to reciprocal your right, and then multiply. 1 times 8 is 8. 3 times 7 is 21. Now, just like before, we're going to bring down everything else. So now we've got a new problem of 8 over 21 divided by 1/2. We're going to rename that, multiply by 2 over 1. We can't cross cancel anything, so we're just going to multiply across. 16 over 21 would be your final answer. And in our last example, the same process, but in this time, it's addition and division. We want to be certainly aware that we always divide before we add. So this would be our first goal. We're going to rewrite that problem as 3/8 times, remember to reciprocal your right fraction. We can't cross cancel, so we multiply. 3 times 3 is 9. 8 times 2 is 16. And now we have a new answer down here, 9/16 plus 1/4. As you know, we need common denominators for addition and subtraction. So 1/4 plus 9 over 16. We'll use the common denominator of 16. Since 4 times 4 is 16, 1 times 4 is 4. 4 plus 9 is 13 over 16, which will be our final example, or our final answer for that last example. So there's a lot to be done when you're dealing with that order of operations, but these are the same skills you followed when you used whole numbers. So now that you've got the new knowledge of division of fractions, you should have no problem completing it. Good luck.